This is Professor Thompson, and I'm going to split the chain rule up into several videos about the different types of chain rule problems, and this one is going to be about when you have several chain rules but no product rule or quotient rule. So my first example is 38 in the book in section 2.5, and this is y equals the square root of x plus the square root of x plus the square root x. So this looks crazy, but we can do it now because of the chain rule. So first I'm going to get rid of this square root notation and use 1/2 notation. So this is the half power of x plus the 1/2 power of x plus x to the 1/2. So I just need to use the chain rule. So the outermost function is this giant square root. So if I'm trying to take the derivative, this thing inside, that's my g, and then f is x to the 1/2, because all of that is plugged into the square root function, because I say it's the square root of, or it's the half power of, all this thing in the middle that I've underlined. So I use the power rule. So it's a half everything inside to the minus 1/2. So I leave everything inside how it was. And then I multiply it by g prime if that thing is g. So now I need to take g's derivative. So keep that part in mind, and I'll do g on the next slide. Okay, so now I've got a new slide, and now what you need to do to keep your head clear on these problems is you need to just forget the rest of the problem and pretend this is a new problem. So I've got this function g of x is x plus x to the 1/2 all to the 1/2, because that's what was inside my square root. So now I'm going to take this derivative, because that's what I need for my original problem. So I just want to take this derivative, and the first piece, just the x, that derivative is just 1. And then the next part requires the chain rule, and again, x plus x to the 1/2 is all inside the square root power. So I do the power rule on the 1/2, and I leave what's inside, and then I multiply by the derivative of what's inside. Well, the derivative of what's inside is 1 plus 1/2 x to the minus 1/2. So there is my derivative for g prime. And so now that's all. This whole thing needs to be multiplied by what I had in the previous slide. And so I don't really need to simplify this. Maybe I can, but I'm not going to worry about it. So my final answer is going to be what I had before, which was this 1/2 times this whole quantity x plus x to the 1/2 all to the 1/2, and then this whole thing is to the minus 1/2. So that's going to be times, so I'll just draw a dot, times this thing I have up here, but the whole thing in parentheses. 1 plus 1/2 x plus x to the 1/2 all to the minus 1/2, and that piece times 1 plus x to the minus 1/2. So that is one long derivative. So you can see these are getting pretty crazy now. And so that would be the final answer. My next example that I'll do is exercise 40. And so this is y equals cosine to the 4th of sine cubed of x. And I'm not 100% sure how many chain rules this will take, so we just need to take it one step at a time. So what I need to do first is I'm going to get rid of this notation, because it makes it unclear what's what. So this notation with trig, where we put the power right by sine or cosine, I'm going to get rid of that first. So this is cosine of the quantity sine x cubed, and all of that is to the 4th. So that makes it more clear what the outside function is. The outermost function is this fourth power, right? This whole thing inside, this would be my G, and then my F is x to the fourth, right? To start the chain rule. So to start, I use the power rule, so it becomes 4, everything inside there, is now to the 3, and then I multiply by G prime of x. So again, like the last problem, I'm going to do G prime of x on the next slide. And then we'll multiply it by what we have here. Okay, so I need to write down this function g of x, and this was the thing inside the power, the fourth power to begin with. And this is just cosine of the cube of sine over x. So now I need to take this derivative. Well, the outermost function now is cosine, and its derivative is minus sine. But I leave what was inside. I don't just write x. And then I multiply by the derivative of what was inside. So if this thing inside is called h, because I already used g, I need to multiply by h prime of x. So forget the big problem. Right now let's just worry about finishing g prime of x. So for the time being, let's worry about h of x being the cube of sine x. And I need to take that derivative. So the outside function is x cubed, so I use the power rule. But I leave sine x inside, and then the derivative of sine x is cosine x, so I multiply by cosine. And now, h prime of x is what goes up here to finish g prime. So g prime of x is now negative sine of the cube of sine x, and then I multiply all of that by 3 sine squared x cosine x. So that's quite a answer, and that's not the whole thing, right? This needs to be multiplied by the function we had originally in the first slide. So I'll connect those on a new slide. Okay, so in the first slide we had this function 4 cosine of the cube of sine x, and then all of that was cubed, and I need to multiply that by g prime. So this is times minus sine of the cube of sine x and then all of that is times 3 sine squared x cosine x. So now this notation where I'm trying to avoid writing things like sine squared x, just to make it clear what's inside and out, because I'm done with the problem, I can get rid of that notation. So the way the back of the book would have this written would be 4 cosine of sine cubed x, and then they would just put the big 3 here. So 4 times cosine cubed of sine cubed of x times minus sine of sine cubed of x times 3 sine squared x cosine x. So again, I'm a bit out of space. Let me just write a multiplication symbol here. And so that'd be the final answer. Maybe there's some arithmetic to do, but I would probably just leave it that way because the simplification can get a little hairy. It's very tempting to try to combine things that don't combine here, or to use some trig rules that won't work. Which is why I use this power notation up by the pink. Okay, so that is number 40.